Welcome to Statistics. This is Unit 5, Who Will Win the Last Banana. This is our second lesson. Oops, sorry. Okay, let's go to the beginning. Sorry, who will win the last banana? Okay, so we played a game today in class. I gave each student a dice, and I put them in pairs of 2. Basically, player 1 would roll the dice, and player 2 would roll the dice. They'd use both values on both players' dice, and if the largest value of the 2 dice shown was 1, 2, 3, or 4, then player 1 wins. If the largest value was 5 or 6, then player 2 wins. And then they would count who won on their tally. I am guessing that player 1 is going to win because there's more ways to win. So when I do this on mine, actually I had player 1 only had a 40% and player 2 had a 60%. So I had, in my particular one, I had player 2 won more games. So the class proportion actually had 58% of player 2 and only 42% of player 1. So the law of large numbers says the more and more the more and more trials that are actually done is the higher probability, it gets closer and closer to the actual probability. So then we're going to actually see what the probability is. So I have my chart colored in a couple of different ways, and I'm going to explain to you what it means in a second. Okay, so first of all, I'm going to have you fill out the chart. The sample space, the chart is considered the sample space, meaning all possible outcomes. So for instance, player 1 is on the column and player 2 is on the row, and player 1 rolled a 1 and player 2 rolled a 1, so a 1 and a 1. The next one, player 1 rolled a 1, player 2 rolled a 2, and the next one, and so forth and so on. The ones that are highlighted in blue, if you notice, the values are 4 or less, which means player 1 wins. The ones that are highlighted in pink and yellow or have a slash mark through, player 2 wins, and because the highest value is 5 or 6. Okay, the reason I have them in pink and in yellow because question A says, what's the probability that player 2 wins with a 5? So that's the pink one. So I count them up and 1, 2, 3, 4, 5, 6, 7, 8, 9, and I get 9 out of 36, or 25%. Then it says, what's the probability that the player wins with a 6? So that's all the yellow ones. If I count those all up, I get 11 of those. And so that's 11 out of 36. Then it says, okay, what's the probability of just winning with a 5 or a 6? And that's where I just have them all slashed in black. You can see a little black slash mark, and you count all those up. And you can notice you can just add those together because if you see A and B are mutually exclusive. Mutually exclusive means 2 events cannot happen at the same time. So I cannot roll and win with a 5 and roll and win with a 6 at the same time. So those are considered mutually exclusive. Remember, the rule says the highest dice is the determining factor. And so I can't have the high dice be a 5 and the high dice be a 6 at the same time. So they're considered mutually exclusive, and I can add these together. 9 plus 11 is equal to 20. And now if you see, player 2 actually has a higher chance of winning. I know you guys thought initially, well, player 1 has a higher chance of winning because they have 4 ways, 1, 2, 3, 4. And player 2 only had 2 ways, 1, 2. But remember, I'm rolling the dice twice, and that changed things up a little bit. And remember, if the higher dice is allowing me to be the winner. So I actually have a 55% chance of winning on player 2. And you can see what we got on ours. We got a 58% chance for player 2 in our class. So we were pretty close, but not exact, which you're not going to expect to be exact, but you are going to expect to be close. All right, and then player 1 is called the complement of player 2 because if it's the opposite. If player 2 doesn't win, then player 1 wins. And so that's 1 minus what player 2 wins, which is about 0.44. Now, I know you see 0.44 plus 0.55 is equal to 0.999 and not 1, but it's really, really, really close, and it's just a rounding issue. Notice if we have A and B, this one here, if A and B are mutually exclusive, probability of A or B is we just add A to B. We have no overlap, we just add them together, and that's what we did in letter A and B here. Okay, the outcomes that we had, the learning target 1, is a probability model, shows all possible outcomes, but you have to make sure each probability is between 0 and 1 because 0 have a 0% chance of having something happen, and the highest probability, 1 or 100% chance of something occurring. all your probabilities must add up to 1. So if I have, for instance, a 30% chance of, let's say I'm looking for a kid, and 30% chance he's in the library, a 40% chance he's at home, then it has to be, and then a 20% chance he's at the movie, then a 10% chance he's at school. That has to add up to 1, and each one of these probabilities has to be between 0 and 1. They all have to be between 0 and 1. And then that would be a good probability model, as long as all of them are between 0 and 1, and the total probability adds up to 1. Because there's only a 100% chance for you to do any certain event. I know coaches tell you give 110%. It's not possible to give 110% because 100% is giving all you have. There's no more above all you have. It's like me having $100 in my pocket and you saying, give me all your money, and I gave you the $100 and there's literally no other money in my pocket. You said, give me more money out of your pockets, and I said, there's nothing left, so I have nothing left to give. You add up to 100%, and that is it. Now, complement of the event. That should say raining. There we go. Complement event's just the opposite of what it would happen. So the probability of raining maybe is 40%. The probability of not raining would be 60%, just 1 minus the actual event. And the little c up in there is equal to the complement. You'll also see it written like this, probability of A prime. Those mean complement also. Okay, mutually exclusive events have no outcomes in common, and we can add those probabilities. If I say, what's the probability of A occurring or B occurring, you can add those two events, and then that will get your total. Okay, let's look at the lesson application. So for the lesson application, I've got person 1 that has a cholesterol of 240 or more, and person 2 has a cholesterol between 200 and 240. These are mutually exclusive events because obviously I cannot have a cholesterol higher than 240 and between 200 and 240 at the same time. I have one value of my cholesterol. All right. The event of A or B, here's A and here's B, because they're mutually exclusive, because they can't happen at the same time, the probability of it being between 200 and 240 and over 240, I just add those two together, 0.16 plus 0.29, and I get 0.45. The complement of the event is I've got between 200 and 240. That's event 1. I've got above 240, and it gives me this. So this is 0.16. This is, I think, did I get it right? Yep. Nope. 0.16. And this is 0.29. Then obviously this is going to be lower than 200, which it did not include, but I know that 1 minus this, because the 0.45 was 0.29 plus 0.16. So 1 minus that is going to get me this, because I know, remember, these all have to be between 0 and 1, and they all have to add to equal 1. So this would be the complement of this, that less than 200 is the complement of 200 or more. And that is it. Thank you for listening, and we'll see you later.